We've understood the properties of images formed by a convex lens for these 4 cases. What if the object is at infinity? Where will its image be formed? All the rays from the object at infinity are considered to be traveling parallel to each other. There could be 2 cases here. First, the lines are all parallel to the principal axis, and second, the lines are parallel to each other but not parallel to the principal axis. In both cases, the parallel rays converge at a single point after refracting from the lens. But there's a small difference. If the rays are parallel to the principal axis, then the point of convergence appears to be the focal point f2. However, if they are not parallel to the principal axis, then the point of convergence may be above or below the principal axis along this line. When the object is at infinity, the image is formed at a single point in space. This point is also called the focus. Since the image is formed at a single point, it's also called a point-sized image. And since it is point-sized, it's extremely small. This is also a real and inverted image. Okay, only one case is remaining in the table. What if the object is kept between F1 and O? I want you to first try the ray diagram for that case. Let's keep our object anywhere between F1 and O. This incident ray, which is parallel to the principal axis, will refract to F2. And this ray passing through the optical center will look like this. Did you observe something? Are refracted rays diverging or converging? Well, they are diverging. It means they are moving away from each other. Does that mean no image is formed in this case as well? Actually, an image is formed. If you extend both the rays backwards, they meet at a point, and this is the location of the image at the top point of the arrow. If I join this point with the principal axis, then I get the complete image. Now, can you tell me its properties? First, we see that it's formed on the same side of the lens. You can clearly see that this is an enlarged image. Also, this image is virtual and erect. With this, we finished all the cases for understanding the properties of images formed by a convex lens. Please go through them once. Now on a new screen, let me only show you the ray diagrams for each of the cases we discussed. All these are ray diagrams representing the properties of images formed by a convex lens. Let me recap all the properties quickly. When the object is between F1 and O, its image is enlarged but virtual in nature. When the object is at F, image is highly enlarged. We assume that the refracted rays meet at infinity because they are parallel. What's next? When the image is between 2F1 and F1, the image is real and its size reduces. However, compared to the object size, it's still bigger, and the image is formed beyond 2F2. When object is at 2F1, image is of the same size as the object and is formed at 2F2. If the object is beyond 2F1, the image size reduces even further. And when the object is very, very far away, then the image is almost a point-sized image. In the next video, we will study the properties of images formed by a concave lens.